Solve log base 5 x plus 1 plus log base 4 x plus 1 is equal to 3. So we're going to use the change of base formula from your formula book, and we can choose to either change both logs to be the base of 5 or both to be the base of 4. That's probably the quickest way to go about doing it, but you could actually make the logs any base that you want, so long as the bases match. So again, you can pick both of them to be 5, both of them to be 4, or you could pick a different number altogether, but it would be much quicker to go with one that's already there. So I've decided to make them both base 4. So I'm not going to do anything to log base 4 x plus 1 on the right hand side, but I'm going to rewrite log base 5 x plus 1 to be log base 4 x plus 1 divided by log base 4 5. So I made them both a base of 4. So I got that from our formula. So the formula is log base bx. So in this case, we had log base 5x plus 1. So the b I've highlighted in yellow is 5. So that's where the 5 comes from there in the denominator. The x I've highlighted in blue in the formula, and in our log it's x plus 1. So as you can see, the numerator, so again I've highlighted in blue, the numerator is log base 4 x plus 1. And then in our formula, the a's are highlighted in pink, so that's whatever log you choose, whatever base you choose for your logs. So I've gone with 4, and they're highlighted in pink as well. Okay, so log base 5x plus 1 is rewritten as log base 4 x plus 1 divided by log base 4 5 plus, and then log base 4 x plus 1 remains the same, and equals 3 remains the same. So this is just the last step on the previous slide. I haven't done anything else. So next I'm going to factorize. So I'm going to take out the highest common factor, which is log base 4 x plus 1. So if we take the first term, which is a fraction, we can see that the log base 4 x plus 1 is the numerator. So that's how we end up with 1 as our numerator, because obviously log base 4 x plus 1 divided by log base 4 x plus 1 gives us 1. And the log base 4 5 just stays the same as the denominator. So nothing changes with the denominator there. And then log base 4 x plus 1 divided by log base 4 x plus 1 again gives us 1. And that's all equal to 3. So this can be a little confusing, but if we multiply this back out, log base 4 x plus 1 multiplied by 1 over log base 4 5. So this is really log base 4 x plus 1 over 1, because anything can go over 1, be divided by 1. So if you're to do top by top, bottom by bottom, it would be log base 4 x plus 1 multiplied by 1, which gives us log base 4 x plus 1. And then remember, there's really a divided by 1 here. So 1 multiplied by log base 4 5 is log base 4 5. And then log base 4 x plus 1 multiplied by 1 is log base 4 x plus 1. So it can be tricky to factorize, but if you multiply it back out, you should get back to what you started with. So then ultimately we're trying to get the x on its own, and we're ultimately trying to get any terms that don't contain an x, so any constants, over to the right hand side or the left hand side, and you could do it vice versa. So since these are being multiplied together, because remember this is a factor, so these are being multiplied together, then to get this on its own, and this is the log that contains the x, so that's what we want on its own. So to get this on its own, we're going to divide by whatever is stuck onto it. So dividing by this will cancel it out, but we have to divide the right hand side by the same thing. So that's why we have 3 divided by 1 over log base 4 5 plus 1. So we have all the constants now on the right hand side. So this is again just the last step from the previous slide. So I haven't done anything here. So I can put this straight into the calculator and get 1.61173. But I'm rounding here, so I'm going to get a little error in my answer, a rounding error. But you can do this and you will still get full marks because you're using a good few decimal places. So the error won't be that much. So then using the scorpion tail method, 4 to the power of 1.61173 will be equal to x plus 1. And then 4 to the power of 1.61173 gives us 9.3402. That's equal to x plus 1. So subtracting the 1, we get 8.3402. So that's what x is. So we can check. So we write out our logs again. So we have log base 5x plus 1 plus log base 4x plus 1. So x plus 1 is going to be 9.3402 because 8.3402 plus 1 gives us 9.3402. So that's why we've got 9.3402 inside both brackets. And that ends up equaling 2.9999, which is obviously very, very close to 3. So there is a slight error due to the rounding here. So another way of doing it, so if I just go back to this step, so again, I have all the constants on the right-hand side and the log containing an x on the left-hand side. So I could actually just apply the scorpion tail here. So we'll have 4 to the power of 3 over 1 over log base 4, 5 plus 1 is equal to x plus 1. So again, that's 4 to the power of 3 over 1 over log base 4, 5 plus 1 is equal to x plus 1. Which gives 9.3403 is equal to x plus 1. And subtracting the 1, again, we get 8.3403. It's a slightly more accurate because we didn't do the rounding in the middle like we did in the previous slide. But it's still absolutely perfect for an answer. So again, we can do our check, and this time we're putting 9.3403 inside the brackets, and we can see that we get 3.000006. So again, not exactly 3, because you're never going to get it exactly perfect because you're going to have to round. But again, this is absolutely fine for an answer. You've got 4 decimal places there. If they don't specify, I would probably go with 4 decimal places. Or you could choose any base. So in the previous example, I made the base 5 be a base 4, so they were both base 4. Or I could have made the base 4 be a base 5, so that they were both base 5. Or I can choose any number at all. So I've decided to go with 2 as a base. I've just picked any other number at all, just as an example. So again, using the change of base formula. So I have to change both of them now, which is why it's a bit longer. So I wouldn't really advise to do this. I'm just doing this as an example to show that it will work. So log base 5x plus 1, which is our first log, becomes log base 2x plus 1 over log base 2, 5. So again, I'm just picking 2. I'm just picking a random number. And then log base 4x plus 1 becomes log 2 base 2x plus 1 all over log base 2, 4. So again, I've just picked 2 as a random number. I could have picked anything really. I just want to show an example where another number will work. It doesn't have to be 4 or 5. But again, this is longer. I wouldn't advise you to do this. Okay, so log base 5x plus 1 becomes log base 2x plus 1 over log base 2, 5 plus log base 4x plus 1 becomes log base 2x plus 1 over log base 2, 4. And again, it's equal to 3. So this is just from the previous slide. I haven't done anything here. So again, I'm going to factorize like in the original method. But we've got 2 fractions now instead of the 1. So notice that the numerators are the same. So that's going to be my highest common factor, log base 2 x plus 1. And factorizing, I'm going to get 1 over log base 2, 5 plus 1 over log base 2, 4. So in the same way that I explained in the previous way of doing it. So the log base 2x plus 1 divided by log base 2x plus 1 is 1. And that leaves us with log base 2, 5 on the bottom. Works the same way on the right hand side. And again, if you want to just check, you can multiply it back out. So log base 2x plus 1 is really log base 2x plus 1 over 1. and multiplying those out, we will get back to the start. And likewise with the term on the right hand side, we will get back to the start. Okay, so then dividing both sides by what's inside these square brackets to get all the constants on the right hand side, we end up with log base 2 x plus 1 is equal to 3 over 1 over log base 2 5 plus 1 over log base 2 4. So this is just from the previous slide. I haven't done anything here. So using the scorpion tail method, we get 2 to the power of 3 over 1 over log base 2 5 plus 1 over log base 2 4 is equal to x plus 1. And then just putting that into the calculator, being very careful because it's quite messy. You get 9.3403 is equal to x plus 1, subtracting the 1. We get 8.3403. Or, going back to this step, what we could have done differently is put what's on the right hand side into the calculator to get 3.2235. So again, you're rounding here, so there will be a slight error in your answer. So now using the scorpion tail method, 2 to the power of 3.2235 is equal to x plus 1. And then 2 to the power of 3.2235 gives us 9.3405 is equal to x plus 1. Subtracting the 1, we get 8.3405. And again, there's a slight error from rounding.